a world 124 light-years away, orbiting a distant star, where the James Webb Space Telescope has just detected a chemical that, on Earth, is only produced by living organisms. Scientists are calling it the strongest hint of alien life ever. And the chances? An astonishing 99.7%. Today, we're diving into K2-18b, a planet that might be more life-friendly than Earth itself. But is it really the discovery of a lifetime, or just a tantalizing whisper from the cosmos? Stay with me, because the story is even more incredible than the headlines suggest. Scientists analyzing Webb's data believe they've found dimethyl sulfide, DMS for short, in the atmosphere of a planet called K2-18b. Here's why that matters. On Earth, dimethyl sulfide is not some random molecule floating around in the air. It's produced almost entirely by life, and specifically by tiny organisms in the ocean, microscopic plankton that constantly release it. We have no known major geological or chemical processes that create this compound without biology being involved. So, if we detected DMS somewhere else in the universe, what's making it there? Here's the part that makes scientists sit up in their chairs. The Webb data didn't just hint at DMS, it suggested its presence with a 3 sigma confidence. In science, that's about a 99.7% probability that the signal is real, that the molecule is truly there in the atmosphere. To be clear, that doesn't mean there is a 99.7% chance of life on this planet. What it does mean is that there is an extremely high likelihood that Webb really did detect something unusual. And here's what makes it even more captivating. The molecule wasn't just guessed at. The team tested dozens of potential chemical fingerprints, running them through models to see which combination best matched the data. Again and again, the models pointed toward dimethyl sulfide, or its close relative, dimethyl disulfide. Either way, these are compounds that, here on Earth, scream life. So the headlines shouting about a planet better than Earth are not entirely unfounded hype. They're based on a tantalizing signal, something we've never seen with this level of confidence before. Picture it, a world more than 100 light-years away, orbiting a faint star in the constellation Leo, possibly wrapped in an atmosphere rich with gases that shouldn't be there unless something is producing them. And right in the mix is a molecule that, on our own planet, is a direct calling card of life. To understand just how extraordinary this claim is, we need to talk about the world at the center of it all, K2-18b. Forget the idea of another Earth, with blue skies and continents surrounded by oceans. K2-18b is something very different, something far stranger. This planet orbits a small red dwarf star, about 124 light-years away in the constellation Leo. At first glance, you might think it's too big to be habitable. It's roughly 2.5 times the size of Earth and more than 8 times as massive. That makes it a sub-Neptune, a class of planets that we don't even have in our own solar system. Not a gas giant like Jupiter, not a rocky world like Earth, but something in between. Why are so many headlines calling K2-18b for better than Earth? On the surface, that sounds like pure hype. After all, Earth is the only world we know that actually hosts life. But when you dig into the science, you begin to see why researchers are using such bold language. First, let's talk about stability. Earth's atmosphere is thin, delicate, and vulnerable. We've seen how climate shifts, ozone depletion, and even solar flares can impact our environment. Now imagine a planet like K2-18b with a thick, hydrogen-rich atmosphere that blankets the entire world. That kind of atmosphere can act like a shield, buffering against radiation and smoothing out temperature swings. For microbial life, that might be a far safer, more stable environment than Earth could ever offer. Second, K2-18b may be a Hycean world, an ocean planet with water covering the entire surface. On Earth, life began in the oceans and still thrives there in astonishing diversity. If K2-18b really has a global ocean, it's not just a place where life could exist. It could be a place where life flourishes on a scale we can barely imagine. Third, consider the chemistry. Earth's biosphere relies on a delicate balance of gases like oxygen, nitrogen, and carbon dioxide. But oxygen is reactive and fragile. Without constant replenishment by life itself, it would vanish. On K2-18b, the presence of molecules like methane, carbon dioxide, and now possibly dimethyl sulfide suggests a rich chemical environment. If these gases are being maintained in balance, that could point to active processes, possibly biological, that keep the system running. Fourth, think about the biosignature itself. On Earth, dimethyl sulfide is produced almost exclusively by marine plankton. We have no known large-scale, non-biological sources. If a molecule like that is floating in K2-18b skies, it may be one of the strongest clues we've ever had that alien life is producing it. That alone makes the case for better than Earth, at least in the sense of detectability. Earth has life, but if you were observing our planet from 124 light-years away, picking out biosignatures in our thin atmosphere would be far more challenging. So when scientists say better than Earth, they don't mean it's a paradise for humans. They mean that for microscopic life, for alien plankton-like organisms swimming in endless oceans under a protective atmosphere, K2-18b might be an even more comfortable cradle than our own home planet. But before we crown this world the champion of habitability, we need to step back. Bold claims demand bold evidence. And as exciting as this discovery is, the scientific community is careful not to jump too quickly. There are serious caveats that we need to confront before declaring victory in the search for life. As thrilling as this discovery sounds, science demands caution. We've been here before, signals that seemed like whispers of alien life, only to fade under closer scrutiny. So, what are the reasons to be skeptical about K2-18b and that tantalizing 99.7% figure? First, let's talk about the confidence level itself. 3 sigma sounds huge, 99.7%, but in astronomy and physics, that's not enough to declare a discovery. The gold standard is 5 sigma, which corresponds to 99.99994% certainty. That may sound like splitting hairs, but history has shown us that plenty of 3 sigma results have later disappeared with more data. Until K2-18b reaches that higher bar, it remains a candidate, not confirmation. Second, there's the problem of ambiguous identification. The spectral fingerprints Webb detected could match dimethyl sulfide, but they might also be explained by other, less exotic molecules. Sometimes multiple compounds absorb light at similar wavelengths. If that's the case, the signal we're seeing might not be biological at all. It could be a product of chemistry that doesn't involve life. Third, we have to remember how faint and delicate this data really is. Webb is collecting photons that have traveled over 124 light-years, filtered through a thin layer of atmosphere around a planet we can't even directly see. A tiny shift in calibration, a bit of background noise, or assumptions in the models could create features that look like biosignatures. The scientists themselves warn that systematic errors are always a risk. Fourth, non-biological pathways are not impossible. On Earth, DMS comes almost exclusively from living organisms, but that doesn't mean alien worlds couldn't produce it through strange chemical processes we haven't yet discovered. Planetary chemistry under high pressure and with different elemental balances can surprise us. We can't assume Earth rules apply everywhere. And then there's the nature of K2-18b itself. This is not a rocky Earth twin with continents and forests. It's a sub-Neptune, wrapped in thick gases with crushing pressures below. For all we know, the environment could be too extreme for life as we understand it. Or if life exists, it could be trapped in niches that are nothing like Earth's surface ecosystems. Finally, there's the community's perspective. While the headlines talk about alien life, the researchers themselves are far more restrained. They're careful to say this is a hint, a candidate biosignature, something that demands follow-up, not a breakthrough announcement that life has been found. The history of science is filled with false alarms, from Martian canals to the famous wow signal. No one wants to repeat those mistakes. So while the possibility is breathtaking, the truth is this. Right now, we have a promising signal, but not proof. It could be the strongest hint yet of alien biology, or it could vanish with the next round of observations. And that brings us to the bigger question. If this signal does hold up, if dimethyl sulfide really is floating in an alien sky, what would that mean for us, for science, and for humanity as a whole? Imagine for a moment that this signal holds up. Imagine that after more data, more analysis, and more debate, the scientific community confirms that dimethyl sulfide truly exists in K2-18b's atmosphere, and that it can only come from life. What then? The first implication would be historic. It would mark the first time in human history that we've found credible evidence of life beyond Earth. Not fossils on Mars, not ambiguous chemistry on a moon of Saturn. Actual chemical fingerprints of biology on a planet orbiting a distant star. That single discovery would answer one of the most profound questions we've ever asked. Are we alone? The second implication is scientific. Confirmation of life on K2-18b would validate the idea of Haitian worlds as prime candidates in the search for life. Up until now, most of our attention has been on Earth-like rocky planets. But K2-18b is different. If life can thrive under a thick hydrogen-rich atmosphere and in deep global oceans, then suddenly billions of planets that we once overlooked might become promising targets. The search would expand dramatically. The third implication would ripple across human culture. Religions, philosophies, and worldviews would be forced to grapple with the reality that life is not unique to Earth. Art, literature, and even politics would shift as humanity redefines its place in the cosmos. The discovery would challenge our sense of importance, but also connect us to something greater, a living universe. And let's not underestimate the technological impact. Such a discovery would turbocharge funding and development for new telescopes and missions. Future observatories like HABEX or LUVOIR would suddenly move from theoretical designs to urgent priorities. Entire careers would be built on exploring worlds like K2-18b, probing not just for microbial life, but for complexity, ecosystems, biospheres, perhaps even intelligent civilizations in the far future. But perhaps the most powerful implication is emotional. For generations, humans have looked up at the night sky and wondered if someone, somewhere, might be looking back. Even if it's only microbes floating in alien oceans, the knowledge that life took hold twice in one galaxy, on Earth and on K2-18b, would mean that life is not rare. It would mean that the universe is likely teeming with biology, waiting to be found. So while today we only have a signal and a lot of questions, tomorrow we could be living in a world forever changed by the knowledge that we are not alone. But before we get carried away, we need to ask, what exactly comes next? How do we move from a tantalizing hint at 3 sigma to solid confirmation? What steps will astronomers take to prove or disprove this extraordinary claim? The next steps are critical. Astronomers know that a 3 sigma signal is exciting, but far from definitive. To move from a hint to confirmation, Webb and other observatories will need to gather more data, carefully and systematically. First, additional transits of K2-18b must be observed. The current detection comes from a limited number of passes, and every new transit provides more photons, more detail, and a stronger statistical basis. The goal is to push the signal from 3 sigma closer to 5 sigma, which is the level generally accepted as a discovery in physics and astronomy. That requires patience and precision, many hours of observing time, careful calibration, and meticulous analysis. Second, cross-verification with other instruments will be crucial. Ground-based, extremely large telescopes or other space telescopes sensitive to different wavelengths can help confirm the spectral features. Independent measurements reduce the chance that the signal is a false positive caused by instrument quirks or model assumptions. Third, scientists will refine their models of K2-18b's atmosphere. They will explore alternative chemical pathways that could produce DMS or similar molecules without biology. They will simulate temperature, pressure, and cloud structures to see how gases might behave under exotic conditions. Only by ruling out non-biological explanations can they strengthen the case for life. Fourth, researchers will look for additional biosignatures. Life doesn't just produce one molecule. It interacts with its environment, producing a network of chemicals. Methane, oxygen, ozone, carbon dioxide, and other trace gases could combine to form a more robust picture of biology at work. Finally, reproducibility and peer review are essential. Independent teams must reproduce the findings, check for errors, and challenge interpretations. Science advances by skepticism as much as by discovery. Only when multiple groups reach the same conclusions can the world confidently claim the detection of life beyond Earth. And even beyond these steps, the discovery of K218b's biosignatures will drive the design of future missions. Telescopes and instruments optimized to detect alien life, not just distant worlds, will become top priorities. This one planet could reshape the roadmap of exoplanet exploration for decades to come. In short, the road from tantalizing hint to confirmed discovery is long, meticulous, and demanding, but the potential reward is monumental. You've just scratched the surface. Tap subscribe, and let's keep chasing the questions that make the world so strange and fascinating.